All right, I am two students. We are talking about 3.1.2, which is I can solve absolute value equations. So our absolute first step every time is we want to isolate the absolute value bars on one side of the equation. So that means it's going to look like something like this. You're going to have absolute value of maybe x minus 7 equals 14. All right, that's what I mean by isolate the absolute value bars on one side. So we don't want to have any number in front of the absolute value bars. We don't want any number or any variable after the absolute value bars either. So it's going to look like this. So we're going to have three examples for our notes. The first example is if the absolute value is set equal to 0, then all we're going to do is we're going to remove the parentheses and we're going to solve that equation just like as if it was a regular algebraic equation. It's simple as that, because when it equals 0, there's only going to be one solution. All right. I'm going to give you another example where it's actually set equal to a negative number, which will be rare. But if you isolate these absolute value bars, let's say now it equals negative 14. Well, that's impossible. It doesn't matter what we put in for x. Whatever you get inside the absolute value bars will never come out to be a negative number. Remember, the smallest number absolute value is going to come out to be a 0. And then after that, it's going to be a positive number greater than 0. So it can never equal negative 14. So if we've isolated the absolute value bars and it equals negative 14, then there's no solution. Now be careful. I'm going to try to trick you on some of these equations. I might have an equation where it equals negative 14, but then we're going to do something to isolate the absolute value bars. And when we do that, maybe we divide both sides by a negative number. That's going to change that negative to a positive. So you don't want to jump to conclusions just because you see a negative on the right side when it's equal to the negative number, unless you've isolated the absolute value bars. All right. And then the last example we're going to have is if it's actually equal to a positive number. So something like this, we know there's going to be actually two solutions. So I'm going to show you how we break this absolute value equation into two algebraic equations that we already know how to solve. And we'll solve to get the two solutions. All right, ready to go? Let's take a look. All right, first example here is we have absolute value of 3x plus 12 plus 7 equals 7. So what do we do first? We subtract 7 from both sides. All right, so we subtract 7 from both sides. So now we've isolated the absolute value bars. Absolute value of 3x plus 12 equals 0. All right, because it equals 0, we know there's only going to be one solution. So all we have to do is we remove the absolute value bars and we write the one equation. 3x plus 12 equals 0. Now it's easy, right? We subtract 12 from both sides. Minus 12 minus 12. And we get 3x equals negative 12. So then we divide both sides by 3. So our answer is x equals negative 4. Oh, could we check it? You bet. Let's plug it back into the original equation. 3 times negative 4, well, that's negative 12. Negative 12 plus 12, 0. Absolute value is 0, 0. 0 plus 7, 7. Does 7 equal 7? Check. It works. All right, let's look at example number 2 now. I have absolute value 3x minus 7 plus 7 equals 2. So we want to isolate the absolute value bar. So we're going to subtract 7 from both sides. And we get the absolute value of 3x minus 7 equals negative 5. So now that we have these isolated, the absolute value bars are isolated, we know there's no number we can plug in for x or substitute in for x that's going to get us a value when we take the absolute value to be a negative number. So therefore, this one will be simply no solution. Okay. All right, last example. This is the classic. This is going to be more of your typical ones that you're going to be solving. So we have absolute value of 3x minus 7 plus 7 equals 9. So we subtract 7 from both sides. So now we get the absolute value of 3x minus 7 equals 2. All right. Now it's a positive number, so we know there's two solutions. So what I want to see you do, and I want to see you do this, I want you to see you break this down into two equations. So see how I have these arrows kind of like this? You're going to break it down into two equations. So it's going to be 3x minus 7 could equal positive 2, or 3x minus 7 could equal negative 2. Does that make sense? Inside the absolute value bars could be negative 2, because when you take the absolute value of negative 2, we get 2. All right? Now we solve both equations. So you get 3x equals 9. We divide both sides by 3. I guess I should show you here. We added 7 to both sides, right, at first. Addition property of equality. All right, so now we divided both sides by 3, division property of equality, and we get x equals 3. All right, that's one solution. The other solution is, the other side, we got to solve this. So plus 7 to both sides. And we get 3x equals 5. And now we divide both sides by 3. So now we get a lovely fraction. We get x equals 5/3. You could write that as 1 2/3. You could write that as a decimal, what, 1.67, we'll say. All right, so those are your two solutions. You can check them. If you go to check them, you substitute the number back in for x and make sure it's true. So if we substitute 3 in for x, I get 9 minus 7. Absolute value of 2 is 2. 2 plus 7 is 9. Check. Ooh, let's do the 5/3. So you're going to go 3 times 5/3. Well, that gets you 5. 5 minus 7 is negative 2. Oh, but wait a minute. Absolute value negative 2? Positive 2. 2 plus 7 equals 9. Check. We got both of our solutions. All right. So I'm going to have you do some of these. Have your notes out. And we're going to go through the process, and I will give you the video solution after each check for understanding, since this is our first day doing this. And don't worry, I don't expect you to have mastered this today. We're going to have more time to practice this tomorrow.